Rendering elements. Elements are the smallest building blocks of React apps. An element describes what you want to see on the screen. Unlike browser DOM elements, React elements are plain objects, and are cheap to create. React DOM takes care of updating the DOM to match the React elements. Note: one might confuse elements with the more widely known concept of components. We will introduce components in the next section. Elements are what components are made of, and we encourage you to read this section before jumping ahead. Rendering an element into the DOM. Let's say there is a somewhere in your HTML file. We call this a root DOM node because everything inside it will be managed by React DOM. Applications built with just React usually have a single root DOM node. If you are integrating React into an existing app, you may have as many isolated root DOM nodes as you like. To render a React element into a root DOM node, pass both to reactdom.render. Updating the rendered element. React elements are immutable. Once you create an element, you can't change its children or attributes. An element is like a single frame in a movie. It represents the IE at a certain point in time. With our knowledge so far, the only way to update the IE is to create a new element and pass it to reactdom.render. T calls reactdom.render every second from a set interval callback. Note: in practice, most React apps only call reactdom.render once. In the next sections we will learn how such code gets encapsulated into stateful components. We recommend that you don't skip topics, because they build on each other. React only updates what's necessary. React DOM compares the element and its children to the previous one, and only applies the DOM updates necessary to bring the DOM to the desired state. Components and props. Components let you split the IE into independent, reusable pieces, and think about each piece in isolation. This page provides an introduction to the idea of components. You can find a detailed component API reference here. Conceptually, components are like JavaScript functions. They accept arbitrary inputs and return React elements describing what should appear on the screen. Function and class components. The simplest way to define a component is to write a JavaScript function. This function is a valid React component because it accepts a single props object argument with data and returns the React element. We call such components function components because they are literally JavaScript functions. You can also use an ES6 class to define a component. The above two components are equivalent from React's point of view. Function and class components both have some additional features that we will discuss in the next sections. Rendering a component. Previously, we only encountered React elements that represent DOM tags. However, elements can also represent user-defined components. When React sees an element representing a user-defined component, it passes JSX attributes and children to this component as a single object. We call this object props. Note: always start component names with a capital letter. React treats components starting with lowercase letters as DOM tags. For example, represents an HTML div tag, but represents a component and requires welcome to be in scope. To learn more about the reasoning behind this convention, please read JSX in depth. Composing components. Components can refer to other components in their output. This lets us use the same component abstraction for any level of detail. A button, a form, a dialog, a screen. In React apps, all those are commonly expressed as components. For example, we can create an app component that renders welcome many times. Extracting components. Don't be afraid to split components into smaller components. Extracting components might seem like grunt work at first, but having a palette of reusable components pays off in larger apps. A good rule of thumb is that if a part of your IE is used several times, or is complex enough on its own, it is a good candidate to be extracted to a separate component. Props are read-only. Whether you declare a component as a function or a class, it must never modify its own props. Consider this sum function. Function sum return a plus b. Such functions are called pure because they do not attempt to change their inputs, and always return the same result for the same inputs. In contrast, this function is impure because it changes its own input. Function withdraw count.total-equals-amount. React is pretty flexible, but it has a single strict rule. All React components must act like pure functions with respect to their props. Of course, application IEs are dynamic and change over time. In the next section, we will introduce a new concept of state. State allows React components to change their output over time in response to user actions, network responses, and anything else, without violating this rule.